Hello and welcome to Stage C, Bipolar Mania. I wasn't going to talk about this, but I'm going to show you why I'm going to talk about this. So I started writing this blurb about the 6 dimensions and 9 lattices we were talking about, which is this here, these different topics, and thinking about trying to find the leverage points within these topics of interest. And so I wrote why we all need to be a little bit manic. Mania changes our cognition, learning style, salience network, cognitive biases, subjectivity, attentional awareness, etc. It changes our diversity of how we perceive and process information. Thus, we have different behaviors, including speech acts and language use, as well as a shift in values and what we engage with. So I wrote that, and in here I had written, and I deleted it, but it said, I hypothesize it has something to do with the right brain. So in my mind, when I read about the right brain and the characteristics of what it has to offer, from, say, Dr. Ian McGilchrist's work or Dr. Jill Bolte-Taylor, so much of it reminds me of the creativity of mania. And so I'm thinking, maybe it's more active. And so I was looking up a study just to see, before I kind of went down that rabbit hole of unfolding that possibility. And I came across a paper. I don't know if this is the one that talks about the right brain, but I eventually got to this paper. Yeah, this one does talk about the right brain. It talks about how the right brain is actually less active in mania, and what is more active is the left prefrontal cortex, left dorsolateral prefrontal cortex, and the left, I don't know about the prefrontal cortex though. So anyways, then I kept reading, and I was thinking about, like what they say about us as bipolar people. So I was talking about how there's elevated and expansive or irritable mood states in mania, as well as increased in goal-directed activity or energy. And there's also symptoms like inflated self-esteem, grandiosity, decreased need for sleep, talkativeness or pressured speech, flight of ideas or racing thoughts, distractibility, psychomotor agitation, and or engagement in risky or reckless behavior. And the way that I see mania or experience it, the way that I experience the increase in energy, it started off like this in the very beginning in 2011. But now it's not really like this at all. Like, I had no decreased need for sleep. I slept just as much last time, where I had more energy. There was no pressured speech or anything. I had ideas that I wrote down. I didn't have any racing thoughts. I wasn't distractible. Didn't have the agitation. I didn't engage in any risky or reckless behaviors. So, maybe I didn't have mania. But so that made me feel like, this is the way that science talks about us. And of course they can say, well, of course we have our time where we aren't experiencing depression or mania, right? But then what I'm trying to say is mania can still be learned from and put to a different use, such that it's not even really that noticeable. It can be adapted to, right? And so their whole point is to prevent mania from happening. And of course, that's a good thing to do, but it's not always ultimately the way it happens. So understanding mania is another way to go about it. So then even if a mania happens, like I was doing creative behaviors, right? Which maybe started off as risky or reckless, and now I don't have the need to like go out and do that when I'm experiencing a mania. So it's kind of twofold, where I was starting to write this blurb here from the perspective of, well, everyone needs to be a little bit manic, meaning neurotypical people, right? So like, am I writing to neurotypical people? Am I writing to people who experience mania? I don't know. And so as soon as I wanted to write something that was maybe to people in general about mania and how it can be beneficial, maybe not mania itself, like throwing someone into a mania isn't a great thing. I wouldn't want to do that to anyone because of all these things here, right? But then what are the positive parts of it that we need in a future with AI? So for example, so we could say spontaneity, and lots of things like that. And this would be maybe the right brain characteristics. You know, so we all need that, and that's sort of what Jill Bolte Taylor is saying in her book, Whole Brain Living. You know, and so for me, it's like, what does manic brain living have to offer? You know, it's kind of like a cross-training thing. And, you know, people might think, well, nothing, but I don't think that's true. So I saw this and it made me sort of like, well, people who experience mania can understand it differently and get the good parts out. So I've already said that. That's Re-Uncovery. And then, you know, there's some increased goal-directed activity. So we have some kind of goal-directed activity, some kind of goal that is different from what we're told our goals are supposed to be, or is different from what our goals have been in the past. So then people see this big change and they're kind of like worried in some way. You know, and then anytime a person is engaging in different behaviors than they were before, it could be risky because it's outside their conditioned pattern that they're used to, right? So like the level of what is risky is, it could be like somebody decides to go to meetup groups or something when they didn't before. I'm not saying that's risky or reckless, but all of these things can be toned down over time, right? And there's no real like training on, well, how do you deal with grandiosity? It's just, oh, you know, you take a pill and you just hope that it never comes back. And so yeah, I just saw these things and it was kind of disheartening. Like, this is, and then not only that, it was saying that our left brain amps up. So it was saying the left brain amps up, and then somewhere in here, there was a reference, or I think it was just another, this is a paper, Cerebral Asymmetry in Bipolar Disorders, a scoping review, and it's from 2023. So in the same search where I was searching for bipolar disorder and the right brain, there was another article here, and this one is Mania-Related Effects on Structural Brain Changes in Bipolar Disorder, a narrative review. So what was interesting here is that they're talking about how the brain changes because of mania. So the structural morphology of the brain changes. And they don't have a ton of studies on this because generally they don't have brain scans of a person before they went into their first mania, so they don't know if those were there before. So if it was like a person was born with that kind of brain, or it developed to a point where eventually it manifested as mania and then bipolar disorder. But they were able to sometimes study a person who, had a scan after a mania sometime, and then had another scan after another mania, or however that worked. But basically their goal was to find out, how does mania change the brain? So it was saying here that we conclude that manic episodes have been related to accelerated cortical volume and thickness decreases. So that means the cortex areas of the brain decrease. They decrease in volume and thickness. And that is occurring in the prefrontal areas. So the kind of where your forehead is. And that's where like our thinking and executive functioning is and everything. Now this part is what caught my interest the most right here. It says, importantly, evidence also suggests that in contrast to healthy controls, who in general show age-related cortical decline, brain metrics remain stable or increase during euthymic periods in bipolar disorder patients, potentially reflecting structural recovering mechanisms. So what does that mean? What they were saying here, which is, the first paper was saying, okay, talking about left brain versus right brain mostly. And then this one is saying that, there are structural changes in bipolar disorder and from mania. And this last part, they're saying that in euthymic periods, so stable periods where a person's not really experiencing symptoms, they stabilize their brain stabilizes or increases. So this cortical thickness and volume decline comes back. So the brain recovers. That's what they're finding. And so they would do a scan of someone, say, who had a mania, and then maybe years later hadn't had any mania, and now their brain is better. So the brain recovers from a mania. And then I looked up the word recover just to kind of like find out more about what they're saying about that in the paper. And it says here that we also propose that patients who remain well may show structural recovery if manic episodes can be prevented, related or unrelated to treatment. So just not going into a mania is not going to, it'll mean that those structures won't decrease in volume and thickness. And I don't know if they've done really enough studies to know this for sure. And where is it? And then here's one more. It says, lithium use has been associated with gray matter volume increase and has been attributed to neuroprotective effects, which might explain the observation that some patients who remain well show no cortical decline or even structural recovery. So they're saying lithium, which may keep people stable, means that they'll just have no decline or recovery because they didn't have any decline. And so now what this made me think of, and because I've done a lot of different research and come across things over the years, this is one that, what is this one about? Is this the same as this one? Yeah, somehow that's on there twice. So the next thing I thought of is related to this, which is brain metrics remain stable or increase during, rest periods in bipolar disorder. This is the brain, right? So now this is an unrelated thing, but I'm going to show you how I see it's related. Because they're saying, oh, it's so bad that brain volume decreases in these areas. It is what it is, but it comes back, right? With rest, it comes back. With deep rest, it comes back. So here, when I saw this, I knew this was important. Basically, they're saying, this is from Science News, and there's no date here. We'll find a date. Brain tissue may be fuel for marathon runners. A study suggests nerve cell insulation, or myelin, that's what the nerve cell insulation is called, is an energy source during endurance exercise. So people who run like long distances. So they may tap into myelin as a fuel source for the brain. So they rely on it for energy during a race, like for their brain or for their body. I'm not sure exactly. And so what they also say here in here somewhere is, after the athlete is done running, they recover. The myelin in their brain recovers. And here's the actual study. So it says, widespread drastic reduction of brain myelin content upon prolonged endurance exercise. So myelin lipids may act as glial energy reserves when glucose is lacking. So the myelin feeds the glial cells when you don't have enough glucose in your brain. And if people are running and running and running, they're going to burn up their glucose in their liver, like the extra storage that is there as glycogen. They'll burn all the glucose in their body, they'll have none left, and then the brain at least starts to feed on